Okay, hey everyone, we're going to start chapter 3 now, which is systems of two variables. So we'll have both an x and a y usually in our problems, and when we do this, our solution will generally be a point, like a coordinate point, x comma y. Or if we're doing a word problem, we will have two different values that will uh, designate whether they're the length or the width or the money or the solutions or whatever they were, kind of like the ones that we did back in chapter 1. So to do a system, you can either solve it by substitution or you can solve it by elimination. Both of them work every time. So it's kind of up to you what you want to do. So some of them might ask you to solve it by substitution or it might ask you to solve it by elimination. But if you have a preference one or the other, it doesn't really matter. I'm going to show you both ways. I will say that I prefer to do elimination method, or sometimes that's called addition method, when we do the word problems. But this one says solve it by substitution. So I'm going to solve it by substitution just to show you how that works. To solve it by substitution, you take one of the equations and you solve it for one of the letters. So for instance, I could take this first equation right here. X plus y equals 5. And I might solve it for y by subtracting the x from both sides. And I'll get that y equals negative x plus 5. Then I could take this and plug it in over here. And I could say that x minus y, which would be negative x plus 5, equals negative 3. And then I can solve this one just for x by distributing the negative across. I would get x plus x minus 5 equals negative 3. Simplify the left-hand side, which would be 2x minus 5 equals negative 3. Then I could add the 5 to both sides. And I'll get that 2x equals 2. Or, once I divide by 2 on both sides, I would get that x equals 1. That's not your whole solution, because remember, a solution to a system has an x and a y. So then we have to take this 1 and plug it back in to figure out what y is. So y would be negative 1 plus 5. And 1 and negative 5 would give you 4. So you end up with the point 1, 4. That would be your solution to the system. These you can also check, but you have to check it with both of them. So if I plugged in 1 and 4 into both of those equations, 1 plus 4 does in fact equal 5. 1 minus 4 does in fact equal negative 3. So you can check them if you want to. This one does work. So we're good to go. Now, a lot of times I will only really prefer to do substitution if one of them is already solved for one of the letters. Like here, we have x equals 2y. Since it's already solved for x, I kind of prefer to do the substitution on this one. So I'm going to take this 2y and plug it in where the x is. And I'm going to say this is x times 2y minus 12y equals 6. 6 times 2y gives me 12y. So I'll have 12y minus 12y equals 6. But in this case, notice the 12y and the 12y, they actually cancel each other. And I end up with 0 equals 6. You might remember we talked about this back in chapter 1. This is a false statement. And if you have a false statement, you have no solution. or you might see the little symbol for the empty set, one of the two. When you're talking about two different lines in this case, no solution or a false statement means that these two lines are parallel. These are actually parallel lines. If you ended up with a true statement where you might end up with 0 equals 0 or 6 equals 6, that is always true no matter what, those are actually the same line laying on top of each other. Okay. Again, this one I would do by substitution since it says y equals 2x. I would take this 2x and I would put it in right there where that y is. And I would say this is 5x plus that y becomes the 2x equals 7. So on the left-hand side, I get 7x equals 7. And divide by 7 on both sides. So x equals 1. That means I actually have a solution. So then I would take that 1, plug it back in over here, and say that y equals 2 times 1. So y equals 2. So my solution here is the point 1, 2. And really, when you're talking about a system, this is the point where those two lines intersect. It is an intersecting point. Now, if it says to solve by elimination, or like I said earlier, sometimes this is called addition method, you want the problems to be in standard form. So that very first one that we did by substitution, it actually would have been easier to do by elimination. But it doesn't matter. If it asks you to do elimination or addition method, what you want to do is wipe out one of the letters. I typically would wipe out the first letters, the X. And so if you'll notice, the 4 and the 2 in front of the X's are both positive. What I could do is I could take the 2 from the bottom equation and put it on top, and the 4 from the top equation and put it on bottom. And that's the numbers that I multiply the equation by. One of them has to be negative, so I'm going to make the 4 negative so that when I add the equations together, they'll cancel. So my top equation will become 8x minus 10y equals 88. I'm multiplying the 2 on each term all the way across. And on the bottom, I'll do that with the negative 4. I'll end up with a negative 8x. 4 times negative 4 is negative 16y. And 9 times 4 is 36. What happens is the 8x is canceled. Then you add together the y's. So I'll have a negative 26y. And then you'll add together the 88 and the negative 36 to get 52. Then if we were to divide by negative 26 on both sides, then I end up with y equals negative 2. To get the x value, you have to plug it into either one of the original equations you started with. I typically just put it in the bottom one, but you could put it in either one. And I'll have 2x plus 4 times negative 2 equals 9. That would give me 2x minus 8 if I simplified the left-hand side. Add the 8 to both sides to get 2x equals 17. 9 plus 8 is 17. And then divide by 2 everywhere. Now, 17 divided by 2 is not really a simplifiable number unless you want to put it as a decimal. So I'm going to leave it as 17 over 2. And so my intersecting point would be 17 over 2 and negative 2. And that's how elimination works. You just take the numbers in front, flip them, and that's what you multiply by. But you need them to be opposite signs. Okay, let's do another one. Here we have 3x minus 5y equals 53. 2x plus 6y equals negative 30. So I'll do the same thing. There's a 2 on the bottom one, so I'll put a 2 on the top. There's a 3 on the top one, so I'll put a 3 on the bottom. I need one of them to be negative so that they'll cancel when I add them together. And multiply it across. 3x times 2 gives me 6x. Negative 5y times 2 is negative 10y. And 53 times 2 is 106. On the bottom, I'll end up with a negative, there it goes. It got stuck for a moment. I'll end up with a negative 6x. 6 times negative 3 is negative 18y. And 30 and 3 make 90. And if you do this the same way that I'm doing it every time, the x's are always the ones that cancel. But there's actually no reason why you couldn't cancel the y's if you'd rather cancel the y's. But I'll get negative 28y, and then I'll get 196, adding those together. And so I just have to divide 196 by 28. So if I'll divide negative 28 on both sides, so y ends up being negative 7. And it doesn't matter which one you plug it into, but like I said, I usually plug it into the bottom one. And I'll get 2x plus 6 times negative 7 equals negative 30. 6 times 7 is 42, so I'll have 2x minus 42 equals negative 30. Add the 42 to both sides. And I'll end up with 2x equals 12. And then divide by 2. So x was 6. So my solution would be 6 and negative 7. And remember, if you want to check it, type it in, put it in either one of the equations. It should work. 2 times 6 is 12. 6 times 7 is 42. So 12 minus 42 is negative 30. You could check it in the other one if you want to, but it should work. Okay, let's try another one. Here we have 2x minus 5y equals 50. 5x plus 2y equals 9. So what I would do is I would notice that there is a 5 on the bottom, so I'll multiply by 5 on top. There's a 2 on the top, so I'll multiply by 2 on the bottom. One of them has to be negative. It doesn't matter which. So I'm going to make the bottom one negative. And I'll end up with 2 times 5 is 10x minus 25y equals 250. On the bottom, I'll end up with a negative 10x minus 4y equals negative 18. My 18 looks kind of like an L. Again, the x's will always cancel if you're doing it the same way that I'm doing it. And I'll end up with a negative 29y. And then 250 minus 18 is 232. And then I could divide by negative 29 on both sides. And so 232 divided by 29, or negative 29, would be negative 8. So I end up with y equals negative 8. Put this back in on that bottom one right there. And I would have 5x plus 2 times y would be negative 8 equals 9. Or 5x, 8 times 2 is 16, so minus 16 equals 9. Add the 16 to both sides. So I get 5x equals 25. Or if I divided by 5 on both sides, I would have that x equals 5. So my solution here would be 5 and negative 8. And again, you can check that if you want to. All right, let's try this one. Some people notice right off the bat that if you double the first one, you get the second one. And if you notice that, that's great. If you don't, that's perfectly all right. I'll show you what happens if you don't notice it. There's a 10 on the bottom one and a 5 on the top one. So I'm going to flip them over and do 10 and 5 the other way around. And one of them needs to be negative. So we'll put a negative on the 5. And what we'll end up with is 50x and 60y equals 50 across the top one. On the bottom one, you'll end up with a negative 50x. 12 times 5 is negative 60. And I'll end up with negative 50. So not only do the x's cancel, the y's cancel, and the numbers cancel. Every single thing cancels. So on the left side, you're left with nothing. On the right side, you're left with nothing. This is a true statement. They are the same thing. No matter what value of x or no matter what value of y you plug into it, they will always work. They will never, ever, ever intersect at one point. They actually intersect at every point. They are the same line. So they're not parallel. They are literally the same line. And so how we write that is that we can either say that the lines are dependent, or you could say that the solution is every single point that x and y is using this first equation. This is one representation of how to write this. They are the same line, and so it works for every single point that is on that line, would be an intersecting point. And that's true if you ever have a true statement, like 0 equals 0, or 1 equals 1, or 5 equals 5, anything like that. Okay, let's try one more like this. If I were to notice there's a 3x on the top one and a 9x on the bottom, I could do the 9 on the top, I could do the 3 on the bottom, make one of them negative. So 9 times 3 makes 27x, 9 times 2 is 18y, 9 times 1 is 9. Then I'll end up with a negative 27x on the bottom, minus 12y, and a negative 24. Here the x's cancel, and that's all that cancels, and that's perfectly okay. 18 and 12 is 30, so I'll get a 30y. Negative 24 and a positive 9 gives me negative 15. So this won't divide evenly, but it'll come out fairly nice. If you divide by negative 30 on both sides, 30 and 15 become 1/2. And so I'll take a 1/2 and put it in up here. And do 9x plus 4 times 1/2 equals 8. And so half of 4 is 2. I could subtract the 2 from both sides and get 9x equals 6. And then to get the x by itself, we divide by 9 on both sides. Now, 9 and 6, again, don't simplify completely, but they do simplify. If you were to divide each one of them by 3, 6 divided by 3 is 2, 9 divided by 3 is 3. This one would be a little harder to check, but it could be done. You have the positive 2/3 and the positive 1/2 for the x and the y. Oh, let's do one more. Somewhere along the way, there's one more. This one you might notice that the 3x is the same already on the front, and the 6y's are the same, but the 2 and the 3 are not the same. This is probably going to give you a false statement, but we'll do the same process that we did on the other ones. There's a 3 on the bottom, so I'll put a 3 on top. There's a 3 on the bottom, on the top, so I'll put a 3 on the bottom. One of them needs to be negative. So I'll end up with 3 times 3 is 9x, 6 times 3 is 18y, 3 times 2 is 6. Then I'll have a negative 9x, a positive 18y, and 3 times 3 is 9, so I get negative 9. What happens here is the x's cancel and the y's cancel, but the numbers don't cancel. So on the left side, I have nothing left. On the right side, I actually have negative 3 left. But 0 does not equal negative 3. This is your false statement again. And so this has no solution. And remember, when that happens, you actually end up with parallel lines. Not the same line, but parallel lines. So they never actually intersect anywhere. Okay, let's go into some word problems. We did word problems back in chapter 1 already. This is just kind of a different take on it. You might have more than one variable to have to work with. And so if it's a mixture problem, I'm going to do the same thing I did back in chapter 1. I'm going to draw 3 little tubs. And so this is my little tubs problem. You have canned juice that is 20% orange juice. Another one is 10% orange juice. You want to mix it together that you end up with 10 liters of 19% orange juice. So you're looking for 2 different values. You want to know how much of the 20% and then how much of the 10% that you're looking for. So if I do the little tub thing that we did back in the day, and depending on how quick you're watching the videos, back in the day might have been just like a little bit ago. My percentages still work the same way. I have a 20, a 10, and a 19. And the one that goes on the end, the last tub, has to be a number between the other two. So 19 is between 10 and 20. I do not know either the 10 or the 20% values. So I'll let one of them be X and one of them be Y. The other one I do know. I have 10 liters of 19, so there's a 10 on top. So what we did back in chapter 1 is that I multiplied the tubs together and I solved it. I do that here as well, but you have 2 different equations now. One equation is strictly straight across the top. I'll use the equation that x plus y equals 10. That is one equation. The other equation is multiplying the tubs together. The 20% times the x plus the 10% times the y equals 19% times 10. So we have 2 different equations here. Just like before, when we did these type problems back in chapter 1, I can get rid of the percent signs by just multiplying everything by 100. Or you could also take the idea of if everyone has a percent sign, then nobody has a percent sign. So whichever one you want to do. But I'm going to multiply everything here by 100. And so my first equation, I'll have x plus y equals 10. The other equation, I'll have 20x plus 10y equals 19 times 10. I'll go ahead and put that as 190. And I solved the same way I was doing the ones before. The bottom one has a 20 in front of the x, so I'll put a 20 on the top. The top one has a 1 in front of the x, so I'll do a -1 on the bottom. And I'm going to have to write that down below here, so it won't go straight across like it did a while ago. But 20 times x is 20x, then 20y, and 20 times 10 is 200. I'll get -20x minus 10y equals -190. My x's cancel. And so I'll end up with 10y equals 10. That's kind of nice. So if you divide by 10 on both sides, y was 1. Now the easier one to plug this into is actually the top one up here, that I could say x plus y, which was just 1, equals 10. So so x was apparently 9. My pen keeps putting extra things on there for some reason. 10. And so x ends up being 9. Now, we don't write this as an x coordinate or a y coordinate. We don't put it in the parentheses like we've been doing. They're going to ask you how many liters of a 20%. So they'll have a blank with 20% solution and a blank at 10%. And you have to know to put the x. The x is over the 20% of the tub. So the x value goes in for the 20%. And the y value goes in for the 10% because the y is on the 10% tub. So hopefully that makes sense. So we have 9, and this is actually liters. I left the liters off, but this is 9 liters at 20% and 1 liter at 10%. So let's do another one of those, except now we're going to do it with pure. Remember, pure from back in chapter 1, that's 100%. 100% pure. Pure acid is added to 10% acid to get 90 liters of an 87%. How much should you use on each one? So same little tubs. We have a tub. We have a tub. And that's equal to another little tub. So we have 100%, that's the pure, added to 10% to get an 87%. I don't know how much of the 100 or the 10, but I know there's 90 liters of the 87. So one equation that I'll use is straight across the top, x plus y equals 90. The other equation that I'll be using is the multiplying the tubs together. 100% times the x plus 10% times the y will be 87% times 90. And I'm going to get rid of those percent signs by multiplying everything in the problem by 100. And so my two equations ends up being x plus y equals 90, or 100x plus 10y equals 87 times 90, whatever 87 times 90 is. Ooh, that's big. 7,830. I had to stop and put that in the calculator. So at this point, the top one will get multiplied by 100 because there's 100 on the bottom one. And the bottom one will only get multiplied by 1, but I'm going to make it a negative so that they'll be opposite signs. So I'll end up with 100x and 100y. That's equal to 9,000. The 90 times the 100. And then I'll have a negative 100x minus 10y equals negative 7830. And my x's cancel. So the 100y minus 10y gives me 90y. The 9,000 minus the 7830 gives me 1170. And then I divide by 90 on both sides to get the y by itself. So if I do 1170 divided by 90, I get 13. And then I would take that 13, put it back up in here, and say that x plus 13 equals 90. So you just subtract the 13 from both sides. So I get 77. Now the x is the 100%. So if I did the little boxes things again, I'd have blank liters at 100%. And I'd have blank liters at 10%. Since the x is over the 100% on the tub, then the x is my answer for the 77 liters of 100%, and the y is over the 10, so that would be 13 liters at 10%. And those would be my answers. Okay, we also talked about money back in chapter 1, so same idea here. We have $9,500 invested, part invested at 11%, part invested at 6%. You make $865. How much is invested at each rate? This is exactly the same problem that we did back in chapter 1. So you could do it the same way we did it back in chapter 1, or you can do it with a system. I'm going to show you the system. So if you do it with a system, you have to have two equations. The first equation is based on how much was invested. So you'd have to have two different accounts that make up $9,500. And I might say that the 11% was the X and the amount at 6% was the Y. But X plus Y has to be the total. And then you do the percentages. The 11% goes into the X account. The 6% goes into the Y account. That made $865. And that's my other equation. Very much like what the equation would have looked like back in chapter 1. So, just like what I did on that last one, I'm going to get rid of the percentages by multiplying this by 100. So I'll have X plus Y equals 9,500. And I'll have 11X plus 6Y. And here, since there's no percent on the 865, you actually have to multiply 865 by 100 and get 865 with two more zeros. Those are my two equations I would work with. Then there's an 11 on the bottom, so I'll put an 11 multiplying on the first one. There's a 1 on the first one, so I'll put a 1 on the bottom one. I need one of them to be negative, so I'm going to make the bottom one negative. And so my two equations then become 11x and 11y. And I have to do 9,500 times 11 to get 104,500. The bottom one doesn't change except the signs. It's negative 11x minus 6y is negative 86500. My x's cancel. 11 minus 6 gives me 5y. 104,500 minus 86,500 gives me an even nice 18,000. And then I would divide that by 5 on both sides. And 18,000 divided by 5 is 3,600. plug that 3600 back in for the y, and we would have x plus 3600 equals 9500, and we'll just subtract the 3600 from both sides. So if you did 9500 minus 3600, you would have 5900. Now, I let the x be the amount at the 11%, and the y be the amount at the 6%. So I'd have so many dollars at 11%, and then so many dollars at 6%. So the 11% goes with the x, because that's what I just let the x be. So the 5900 goes in the first blank, and then the 3600 would go in the second blank. I made the blanks kind of small, didn't I? Okay, one type of problem we didn't talk about in chapter 1 was these type problems. And they work kind of like if you're doing the mixtures with the solutions with the percentages. They work kind of the same idea. Not quite, but they're pretty close. A store mixes two different types of grass. One is at $10 per pound, sells for $10 per pound, and the other one sells for $14 per pound. What they want to do is mix the two and sell it for $11 per pound. They want to know how much of each should be mixed together to make a 312-pound mixture. So you're mixing it all up, and you want to end up with 312 pounds that it can sell for $11 per pound. Well, I'm going to let the red fescue be my x, and the ryegrass be your y. So if I add those two values together, that has to be the total amount that I'm going to have. So I'm going to have x plus y equal 312. That's the amount of grass seed that I want to have when it's mixed together. My other equation is kind of the money equation. The x, the red fescue, sells for $10 per pound. So I'm going to have $10 on the x. And the other one sells for $14 for the y. And I got to mix it up to get an $11 per pound at 312 pounds. So I take the previous equation, the x plus y equals 312, and then I multiply by how much I want to sell each one of them for. And that's pretty much it. There's not a whole lot of simplifying on this one like the percentages, except for the 312 times the 11. But I'll do that when I finish multiplying as well. So the top one will get multiplied by 10 because there's a 10 in front of the x. The bottom one will get multiplied by 1, but we'll make it negative so they'll cancel. So I'll end up with 10x plus 10y equals 3120 because I multiplied by 10. The bottom will give me a negative 10x minus 14y, and I'll get 11 times 312, which would be 3432, which will be negative 3432 because of the negative 1 I'm multiplying across. My x's cancel, so I'll get a negative 4y, and I'll get the 3120 minus the 3432, gives me negative 312. Then if I were to divide by the negative 4 on both sides. By the way, keep in mind, you can use a little bit of logic here. It's not possible to get a negative value on here. So if you get a negative value, that's bad. So your y comes out to be 78. And I'll plug that y back in on that first equation, way back up here. and I'll say x plus 78 equals 312, and subtract the 78 from both sides. So if I did 312 minus 78, I get 234. So the question is, how much of each would be used to make the 312 pound? Well, X is what I said was the red fescue. So you need 234 pounds. Oops, no, it's supposed to say of the red fescue, or fescue. And you need 78 pounds of ryegrass. Because I let Y be the ryegrass. And that would be your answer. Okay, last problem. There are 323 tickets sold for a basketball game. And student tickets cost $1.75, where adult tickets cost $2. The total amount earned from the ticket sales was $598. You can figure out how many of each kind were sold just from that particular amount of information. So it's kind of like the last one. There were 323 total tickets sold. So I have to have one of them be X and one of them be Y. So I'm going to let the students be X, the adults be the Y. And so I know all of the students and all of the adults made 323 tickets sold. The other equation is the money equation. So the student tickets were $1.75 each. So I'd have $1.75 for the X. And I would have $2 for the Y for the adults. That would give me a total amount of money of $598.75. Notice on the last one, I had to do the poundage times the money. Here you don't. You know the exact amount of money that was sold, that was made. And so we could just use the $598.75. So I can just go ahead and jump in here. I would multiply the top one by $1.75. I would multiply the bottom one by 1, make one of them negative. So we end up with $1.75 X plus $1.75 Y equals, and then I would multiply the $1.75 times the 323. That's $565.25. The bottom one just becomes negative. Negative 171.75x minus $2 on the Y, and a minus $598.75. And again, using a little bit of logic, your X and your Y have to come out to whole numbers here because you can't have half of a person going in the game. And so your X's cancel. 1.75 on the Y minus the 2Y gives me negative 0.25Y. On the right hand side, if I do the 565.25 and subtract off the 598.75, I get negative 33.5. Then I can divide by negative 0.25 on both sides. And hopefully this gives me a whole person. Yeah, it gives me 134. Which is good. You have to have a whole number. You also have to have a number that's less than 323 because that's how many tickets were sold. And then this goes back into this first equation. So I'd plug this back in right there. And say that X plus 134 equals 323. Subtract the 134 from both sides. And so 323 minus 134 is 189. So I let X be the students. So there were 189 students that came to the game, and there were 134 adults at the game. And that is all of that section. So we're done with this part now, and hopefully that makes sense. Again, if you have questions, let me know. And don't forget, we also have TA office hours as well if you'd like to ask one of the TAs too.